All right. Well, welcome everybody to get back to Groovy. This section is open to everybody, children of the 60s as well as, teachers, younger teachers in a different generation. I'm Eric Archer. I'm from Texas Instruments, and my partner in crime today is Fred Fotsch, who's online right now. Fred, you want to say something?
Good morning, Eric, and good chilly morning to everyone. I think it's cold all over the country, so stay toasty during the session.
That's right. Yeah, one nice thing about doing it virtually is you can do it in the comfort of your your own thermostat settings, which is kind of nice. With that, I want to get into the content very quickly. We only have about 40 minutes to show you what TI has to offer for you and your students. There's some exciting new things that are available from TI. And one of those things is Python programming. And so we have now available to you Python programming on the convenience of a TI graphing calculator. And so our latest graphing calculator is the TI Inspire CX2. That's a mouthful. But with that calculator, it comes built in with Python programming. And there are a lot of cool benefits with Python on the calculator. One of those is the fact that you can take your calculator anywhere that you want. Your students can program anywhere. So for example, if your school is low on computer labs, you have more students that want to do computer science and you have computer labs for them. An alternative could be that you get a set of calculators and your kids can do Python programming concepts right on the calculator. If it's the gymnasium, they can do it there. They can do it outside, anywhere you can take the students, they can do programming. Now, a couple of things that are unique to TI's Python programming is that instead of having to know the syntax off the top of their heads, they can do it through menus. And so all the commands and methods are done through menus. We also have something called inline prompts, which is really nice. Now, Fred will show some of this to you in his demonstration here in a couple of minutes. But for example, if there's a line of code that requires some input, say some numbers, you will be prompted. The student will be prompted to enter or to choose that information. And then finally, we do support Python modules. TI has created some of our own, as well as support very popular TI or Python modules that are popular with folks. So Fred will he might talk a little bit about that as well. One of the projects that we've done recently is TI STEM projects. And let me take you back to that webpage. It's at www.tistemprojects.com. That's going to take you to this page. And there are a ton of projects that you can do with your students, either in your classroom, in a summer STEM camp, before exam, or even online. We've recently adapted to the COVID environment of doing things online, and we've worked with a bunch of students and teachers this past year online, helping them get started with STEM activities. Now, all of our STEM activities are done in TI Basic, which is a traditional coding language. It's very accessible, very easy to use. But recently, we've adapted our Moodring project, which is why you're here, to the Python programming language. And it's a really nice set of videos that the students can watch on their own, or you can kind of guide them through it. The concepts that are covered in this project that Fred's about to demo, we mix in some nice science, mathematics with the coding concepts. So the students will learn about color mixing, a little bit about the electromagnetic spectrum, feedback and control systems, how to read temperature from a sensor, and what to do with that information, as well as loops, conditional statements, and variables. This project's got a lot built into it. Now, if you don't have TI technology in your school, that's fine. It's okay, because TI has a very generous loaner program. So look, we're not trying to sell you on buying TI technology. What we're trying to do is enable you to do some really cool STEM projects with your kids using TI technology. And if that means that you need to borrow it from us, that's fine. We have a great loaner program. We pay for FedEx to ship it to you. We'll pay FedEx to ship it back from you when you're done with it. And that's available to everybody on this call right now. So if you want to do that, let one of us know. We'll put our contact information in the chat, and we can get you set up. So this project, though, this is the one we recommend folks start with. And like I said, there are two parts to the project. There's a sort of the Explore the Science of Color, where they do some introductory coding and they learn about color mixing. And then part two is where they do a lot of a little heavier on the coding, and they're coding the ring to actually work. And they're going to use a red, green, blue LED. And with that, I think I've covered sort of the introduction. I want to turn it over to my colleague, Fred Fotsch, to walk you through all the things I just mentioned, so he can actually demo it for you. And Fred, are you ready to do that?
I am, Eric.
I'm going to stop sharing, and I think it should be,
okay.
You should be able to share now, hopefully.
Yeah. All right. Can you see my screen okay, Eric?
Yeah, I see a video of your calculator right now.
Okay, great. Well, thanks, Eric, for all of that. What I'd like to show first is just the calculator. So this is the calculator right here, and this is what we're going to use for all of the TI STEM projects and to do our Python coding. Now, the mood ring is a kind of a thematic project where students model a mood ring, which for those of you who may not recall, the mood ring is a fashion accessory, a piece of jewelry. You put it on your finger, and according to the temperature of your finger, it changes colors, and then there's a mood that's assigned to that color, which of course is not scientifically accurate, but it's fun. And so in this project, we model the mood ring. And so this is done in Python, along with a lot of interesting science and math to support the project and to support their learning in these other subjects. Now, the mood ring itself has several different the project has several different paths that one can take. You can do kind of a quick path where you just focus on the coding, or you can take a longer path where you actually participate in a little bit more of the science and the math. But as the teacher, you can choose what it is that you'd like to do. If it's in class, you might want the shorter version, but if you want to do a STEM camp at some later time in the summer, or when your school may have time, there's a longer session that's available. So that's kind of the mood ring in a nutshell. So the mood ring is an example of physical computing where students interact with some physical device. And in this case, the physical device is the model of the ring itself. So how does one model a mood ring? Well, one way is to use a microcontroller-based type of device. In this case, we're using the TI Innovator Hub, which is a microcontroller based upon Texas Instruments MSP432. And we need a ring. And so in this case, I'm using a sensor, and this sensor is just a little temperature sensor. It's very inexpensive. This is part of what the STEM team will lend to your class if you want to do this in your school. And it simply plugs in, and the hub has inputs. It also has outputs. And then it has some built-in sensors like a brightness and a speaker and a few other things like a color LED. And then there's also a breadboard port for really getting after some fancy STEM type projects that incorporate a breadboard. But the way that one would do this project is they would take this sensor and they would plug it into N1. And then they would take what we call a unit-to-unit cable. It's just a short little cable. And this cable plugs into the USB port of the calculator up at the top there. And then it plugs into the data port of the hub right here. And when you turn it on, you can see that it kind of boots with a little LED that indicates that it's up and running. So this is the platform that your students would use. And so as you can see, it's a small portable platform. It fits on a desktop nicely. It can go in a backpack if you choose. And everything that you need for Python is built in. There's no having to get with IT to install it or anything like that. It's good to go. Now, you as a teacher, of course, want to be able to demonstrate with the students. And so what I'm going to do is show you a emulator that we have for the calculator. And that's what this is here on the left. This is actually an emulator, and it is going to act just like the computer or just like the actual calculator. And so this is great if you have like a smart board or something like that. You can interact with it just like the students do. Of course, it's a little difficult to see on my screen right now. So what I'm going to do is I'm going to switch this and put it into a different mode where I have a little side screen here that shows me a little bit more. And what I'm going to do is I'm going to unplug my actual calculator, and I'm going to kind of use this virtual calculator, that's over here on my screen. And I'm going to do that by just taking my just a regular PC cord, USB cord, and I'll go ahead and plug that in here. And you can see that when I plug it in, it starts up the hub just like it did on the calculator. And so now this is a live working connection with this device over here. Okay. So Eric, can you still see my video just fine?
Right, I can see it.
Excellent. Okay. Just want to make sure we don't lose any connections along the way here. I'm going to kind of go into another view of this document just to tell you a little bit about the TI Inspire itself. The TI Inspire has documents that can have several pages. Think of this like a PowerPoint. This document that I'm using is pre-authored and available on the internet under the STEM projects page, as Eric pointed out. And in here, there is content and examples. Now, this is kind of the teacher version, so it has example Python code in it. Of course, this is not what we'd want the students to use. But there's also multiple choice questions that can be answered and saved, and the teacher can check at a later date. And so there's a lot of different types of problems that are in here. Just to kind of show you some of the power of this also is Eric mentioned that there's a lot of science of color mixing in the first part of this mood ring. And here's a simulation where students can actually mix red, green, and blue colors and see the interaction of those colors. And so you can see the secondary colors of, excuse me, yellow and magenta and cyan, and then the tertiary of white. So all that's kind of some cool stuff that's in here. So the calculator then has many different features in it. Of course, it can do math and graphing and that sort of thing. But what we're interested in is the computer science aspect and also some of the supporting simulations that are possible as well. But what I want to do right now is to kind of show you how do you get started with a Python program on the calculator. So to do that, I'm going to just kind of start from scratch. I'm going to kind of show you kind of how this would start. So you would turn your calculator on, and then you would choose number 1, new document. And you can see down at the bottom, under letter A, you can either open up a new program in the Python editor, or if you choose, you can go directly to the shell. So this is just like a typical Python environment on a PC. There's an editor and a shell, and the interaction between those two is pretty seamless, which I'll show you. So I'm going to choose number 1, make a new program, and I'll just call it CSTA. And now here I am in my editor. Now, as you all know, to extend the functionality of Python, we typically add modules. There are many modules that are available in the TI Python environment. TI-plotlib is kind of a small version of matplotlib. And there are also a number of other modules, like, for example, a image processing module. There's a pixel graphics module. There's a way to interact with the calculator operating system, and a number of other things. There's a turtle module and some other modules that are going to be coming soon, such as microbit. So I'm going to go back then, once I've kind of thought about this, and I'm going to go to menu, and I'm going to go to TI Hub number 8, and I'm going to import that module. And so here I've imported the module, and I want to just make a quick little program that interacts with the RGB LED. And so I'm going to do that, again, by going back to the hub, and I'm going to choose number 2, built-in devices, because these are devices that are actually built into the hub. I'm going to use the color output, that's the color LED, and I'm going to choose the method RGB. And so I want you to notice one thing here real quick, is that all of the commands and syntax that are available in the Python environment are in menus, which makes it very discoverable for the student and also the one who wants to explore. And it also shows you parameter values that are required for those methods. And so I'm going to choose number 1. And now notice that the cursor highlights the first parameter red, and it said you need to have a value between 0 and 255. So I'll put in 255. I'll press my tab key. Again, you see that range of valid parameters. I'll put in 0. I'll press my tab again, and let's put in 128. And now to run this program, I just go to menu, and I go to number 2, and I choose 1. Also notice parenthetically that there's a key command sequence that can make a shortcut for you. These are just like the ones on your computer. In this case, Control R will run this program, but I'm going to choose it from a menu, and I press number 1 to run it. And notice what's happened. First off, you see over here a shell has appeared, and it imported the program, csta.py, and it executed it, and that code creates a magenta color on the RGB LED. So that's kind of an example of how to use the color LED, the RGB LED. And if you wanted to get into the science of that, there's all sorts of supporting science to go along with this. There's videos that the students can watch so that they can learn about all of this. But today, our task is to kind of learn a little bit more about the Python editor. So what I would like to try to do is to show you some of the kind of essential steps that are in the mood ring. So one of the things that we're going to do, remember what we're trying to do is to model an actual mood ring. And so remember what that mood ring kind of looks like here. That mood ring has kind of a stone, and that stone changes colors. Well, we're going to model the color of that stone with the color of the RGB LED. And then the ring also fits onto the finger, and it interacts with the temperature of the finger to change the color of the stone. And so in the project itself, a little piece of chenille wire or kind of fuzzy wire is supplied with the temperature sensor, where they can thread it through these holes, and they can put it on their finger just like a ring. And then this temperature sensor picks up the temperature and runs it into the hub, and then it digitizes that and it sends it through the cable into your Python program in real time. Your Python program can make decisions based on that temperature, and it can change the color of the LED, and also it can print the mood that's associated with that color. So you can see kids have a lot of fun by creating the color combinations, the mood messages that go along with the mood ring project. So with that said, let's kind of go back to where we were in how do we do some of this. So what I want to do is I want to connect this temperature sensor. So I'm going to show you the process of the construction of a temperature sensor object. So I'm going to do that by going to the menu. I'll go to number 8, TI Hub. Now I'm going to add an input device because I've plugged this into the N1 port. I need to kind of keep that in mind because I need to make this connection between hardware and software. And that happens in this construction that I'll choose with number 3, add input device. And this is a temperature sensor, so I'll choose number 4. Now, this is a construction of the temperature class, and I'm going to make an object called ring. And when I press tab, you'll see over there, there's a prompt that says port. By port, it means this physical port right here. And if I press tab, it gives me valid ports to do this with. So I'm going to choose number N1, and that gives me the ability to create a temperature object. So I've created this temperature object called ring, and it's connected to N1. Now let's do something with that temperature object. Well, first off, notice when I press the var key, the object that was just created now is populated under the variable key. So let's choose that ring object. And before I do that, though, I want to think about what I want to do with this ring object. I would like to measure its temperature. So I'm going to just make a variable, and I'll call it temp. And I want this temperature to be from the ring object. And when I press the dot, it pops up the valid methods for this object. And measurement is what I want to do. So right there, I've just invoked a measurement from the ring object, and I'm taking that value and I'm putting it into a floating point type of variable named temp. Now let's print this. And so I'm going to go to menu, and if I go to number 4, built-ins, these are the things that are built into Python that you would see under pretty much any Python implementation. So for example, under control, we see, you know, all of our decisions and definite and indefinite loops. Under ops, we see that there's all sorts of, you know, comparison operations. It fully supports lists, and all of the different methods and functions associated with lists are there. It you know, allows you to you know, manipulate variable types. And now under I/O, this is what I was looking for. Print. There's print. And so if I choose print, now the first thing I can do with my print message is make a little prompt. I'll go ahead and say that the temperature is equal to, and I'll close that quote for that string, and I'll delimit the string with a comma. And now, remember I made this variable called temp, which is actually the return value of the method measurement of the object ring. And so I'm going to go back up here to var, and hey, look, there's my temp. So I can just come down here and I can populate it right there. Again, I'm going to put a follow-up of a unit on here. So I'll press the quotes one more time. And there are a lot of symbols that are available to you on the calculator that you can add into strings. And so here I have a little prompt for my centigrade degrees. So now these 3 lines basically have made a program that constructs the ring object that's actually a temperature sensor. It stores the measurement of that temperature sensor into the variable called temp, And then I'm going to display that on the calculator's screen with the appropriate prompt and unit. So I'll use that key sequence that I referred to, Control R, to run this. So I'll press Control R, and you can see it's pretty nippy in my my house today. And so let's say I wanted to do this several times. So let's do that. Let's put this into a loop. So I'm going to put this in a loop. I'll go to Menu, and I'll go to number 4, built-ins, and I'll go to Control, and go down to number 4. And this, notice again how the structure is populated with all of the required prompts. And so I'll just say my index variable is in, and let's do this 20 times. And if I were to press tab, it would start coding right there and already automatically indent it. Notice there's those 2 gray diamonds to illustrate that ever so important indenting concept in Python. But I've already got my code written that I want. So I'm going to just go down here and I'm going to grab this and kind of appropriately indent it. And so I'll indent both of these statements so that they're within the loop. Now, this will go blazing by pretty quickly. So what I'm going to do is I'm going to put a little pause in here. So I'll go down here to number 8, TI Hub, and number 5, and I'm going to use sleep. Now, this is part of the time module, but the time module is automatically imported with the hub. And I'll just put in a sleep of ½ a second, and we'll run this. And you can see that there's my temperature. I'll take my warm coffee and put it on there. And even with my warm coffee, it's not particularly warm in here. But you can see the temperature changing. So this is kind of a quick rundown on the Python environment. What I'd like to try to show you now is the actual mood ring. So I'm going to go back to the mood ring file, and this is the teacher edition, and it's the second part of that teacher edition. And I'm going to scroll down here, and I'm going to go to the actual running mood ring program. And here it is right here. And so let's take a look at this. I'm going to change my view a little bit so you get a bigger view of this. And you can kind of see what's happening. So I've imported my hub module. And then I've done my construction. This time I called it my temp instead of ring. Now this is really a nifty little helper right here. This is under the system module. It's a TI thing. But what it is, it's an indefinite loop that embeds the polling of the calculator keypad. That's what the get key function does. And the get key function will return the string ESC when the escape key, that's this guy right up here, when that escape key is pressed, it will return this string. So the get key will return escape when it's pressed. So we want it to evaluate to true so that this runs indefinitely. And so we use the not operator to say when it's not equal to escape, that's basically when it's just running, just do everything that's in here. Well, what am I going to do? Well, here, this first statement right here is getting the temperature T from the my temp object that I just constructed here. And I'm using the method measurement, and I'm returning that value to T. That's just like the example I just worked. And then I'm using something from the TI system module that displays text. Instead of on the shell prompt, it displays it in kind of a graphics area, which actually makes it run and much nicer because it creates a kind of dashboard. And now here you can kind of see some if-then statements that are going on here. And, you know, of course, you could use else if in here and all of that, but I've tried to keep this just as simple as possible for introductory Python programmers. So we just have a series of statements. And if the temperature is less than 20, we display a mood message of I feel happy. And here's the color that I'm going to display with it. And so this is really how we model our mood ring, is by measuring temperature, then making a decision based upon that temperature. We set the color LED over here to the appropriate color for our gemstone. That it's actually not a gem, but for the stone that's in the mood ring. And then we display the appropriate mood message. And so I'm going to go ahead and run this for you. I'm going to put it back into the view of the calculator here. And I'm going to run this, and hopefully I've got enough heat left in my coffee cup to change the temperature. We'll see. So I'm going to go ahead and go to that Control R. And you can see that here's my kind of dashboard. It's displaying temperature, and you can see over here, there's the temperature of the mood ring stone. And now if I were to put this on my hand, it probably wouldn't change because my hand's cold too. But if I put it on my coffee cup, which isn't particularly warm, you can see that the temperature starts to go up. And I think that our trigger was at 20. And there we go. It says, I feel hopeful. So I'm feeling hopeful right now that the temperature of my coffee is a little warmer. And there it changed once again, and a mood message of meh. So hopefully you're not feeling meh today. Hopefully you're feeling happy. And so this is kind of an example of how the mood runs. So to exit out of this, I'm just going to press the escape key so you can see it running. And I'm going to press the escape key right here. And the escape key will take me back to the prompt. And so here I am in the shell. And if I go back to a page, you can see there's my code. And so this is kind of that page-based document, a bit like a PowerPoint, that shows you the editor and the shell. To go to a little simpler view, I'll go to that document that I opened before. So here you can see there's the prompt, and I can actually, go to the ring, and I can actually get measurement here and return that. And you can see that even at the prompt, the ring object exists, and it can return the method value. And so this is kind of a quick rundown of the TI Python platform for the TI Inspire. And as Eric mentioned, there's a lot of videos that go with this to help a new Python student get started. So this would be a great project for a Principles of Computer Science class. And you can see it's also pretty engaging for the students to get involved with the physical computing of this and thinking about messages and colors. It's kind of creative for them. And this is a project that is it is an effort to teach the students coding. But once they've done this, they can do a little more freeform. They can, start to build their own projects and write their own code. And we have projects that are much more open than this. So this one is kind of a getting started type of project. So at this time, Eric, I'm going to turn it back over to you. And perhaps you can kind of tell us a little bit more about some of the resources. And then if there's some opportunity at the end there, we'll also take some questions. So I'm going to turn this back over to you right now. I'll stop sharing. And so now, Eric, back to you.
Fred, thanks for that. Fred, great job on the demonstration. Hopefully you guys were able to see what Fred was doing, because there was so much involved there. There was some introduction to Python coding, really coding concepts in general. I mean, a lot of the concepts that Fred was showing are concepts that kids learn regardless of what language you may be using. And so, there's a lot there. And the other thing too that he was showing was physical computing. So he's using, physical devices. He's using input sensors to control outputs. And so he was measuring temperature to control what the screen would display, as well as what the LED would do. And so, so there's physical computing, there's introductory coding, there's coding concepts. There's also a whole bunch of science concepts. And again, all of the projects on this page tistemprojects.com, and I'll put that in the chat once more. All of the, or Fred, if you could put that in the chat, that'd be great. All of the projects are available. They're all free. Again, if you don't own TI technology, don't let that be why you don't do these projects, because we will loan you all of the equipment for up to 30 days. And in some cases, if we don't have high demand at the moment, we'll let you keep it a little bit longer. And like I said, we'll pay the shipping to get it to you, and we pay for the shipping to get it back. The cost to you is a little bit of time and getting it set up. And by the way, if you need help, if you feel more comfortable knowing all of the ins and outs of the coding, we'll get on the phone with you and we'll walk you through all of it. And there's no cost to do that. We just have to schedule time to do it. Our team, we are the TI STEM team, and there are about 4 of us. And we have worked with hundreds of teachers and thousands of students over the last several years doing exactly what I'm talking about. So please, if you want to do some STEM with the kids and you want to do some physical computing and you're a little nervous about it, don't let the equipment or the fact that maybe you don't know Python yet, don't let that stop you, because we can help you get up and running. What you have to do is you just come to this website, tistemprojects.com. The project that Fred specifically mentioned under Moody Hughes, and it has the little Python icon next to it. It's the only one right now that does Python, and you click on that, and that will take you to the project. But if you want to fill out a request form, you go to Get Started Now. It's a big red button on the tistemprojects.com site, and you click on that. It'll take you to this little form here. And all we're asking for from an information point of view is your name, how to send it to you. I need an address and a phone number, because FedEx requires a phone number for you. What you're teaching, what grade levels you're doing, which projects you're interested in, because again, you can do multiple projects. Right now we only have Python for Moodring, but you can do TI Basic with all the other projects. Rover, we haven't talked about Rover, but TI Innovator Rover is a robotic vehicle controlled by the calculator. Kids love it. It's a lot of fun. There's a bunch of projects there. You can borrow rovers from us as well. Calculators, when your event's going to be, when does it end, largest class size, so we make sure we send you enough equipment. And again, if you need to do this online, we can help you with that as well. And so please take advantage of this resource. We'd love to work with you, love to help you out, and get you up and running on this stuff. Again, the TI STEM team, it's Fred Fotsch, myself, Dave Santucci, Steve DeBoge. We're all here for you, and our job is to help you get STEM in your classroom. Fred, what did I miss there? I probably missed something.
Well, Eric, could you give us kind of a quick show of those video resources that are available for this project?
Good idea. So when you come to the Digital Moodring page, and again, try not to flip around too fast here, but if you scroll down to Moody Hughes, you see that little Python icon next to View TI Inspire CX2 Python Activity. I'm going to click on that. It'll take you to the specific page for Digital Moodring Python, and then this just breaks down what you're going to learn. And again, some of the concepts are color mixing, some cool math applications of inequalities, and that's where that whole conditional statement comes into play. So if the temperature is greater than X and less than Y, then I'm going to turn on blue and put up I am meh, like Fred showed you. Now, the project versions, there's flexibility here. So if you have up to 6 hours of class time that you can use for this, we have a 6-hour version of the project. If you only have up to 4 hours, we have a 4-hour version. And let's say you only have an hour, we have an hour version. And so the color coding denotes which version of the project you have available time-wise. And then you come down to the actual videos, and you'll see the video is coded with what code. So, for example, this first video is necessary for all time constraints. So if you only have an hour, you still need to do coding challenge 1. If you have 4 hours, you still need to do this project, and so on. Now, the 6-hour version you'll see has S's, 4-hour has C's, and 1 hour has Q's. So you get the sense here. You don't need to watch all the videos. Your kids don't need to watch them all if you don't have all of the time available. But what it does is it builds in a lot of cool flexibility for doing some really interesting science concepts. But let me show you one of the videos. I don't know how well this is going to do on, online here. Let's see. You probably won't be able to hear too much of this, but I'm going to use the thumbnail view to kind of give you a sense of what the videos entail. So the narrator of the video, which is Fred, he'll show you everything step by step. So if you've ever fixed your faucet by watching a YouTube video, you realize how important each step is. Well, that's kind of what this is. Fred walks the kids through every aspect of the project. He works in a lot of, interesting information as well. So it's not just Fred doing step by step. He also works in some interesting factoids about some science concepts. One of my favorite videos that he does is he gets into the art of particle. And so when you look at your television screen and you see all the pictures, well, the pictures are made by millions of pixels that can change colors with R, G, and B. And so Fred breaks that down about how artists in the past have done that with little pinpoints of paint. And so it's not just fix your faucet. It's also some really interesting tie-ins to art. And so here's an example. So this picture was painted not by brush strokes, but by little pinpoints of paint. And so you can imagine there's probably hundreds of thousands, if not millions, of little pinpoints of paint in this picture. And we relate that back to what you're doing with the RGB LED and the coding. So those videos are free online. You don't need to log in. They're just there. I think my colleagues have put the links in the chat. And I also want to put up one more important link before we go, because I know we only have a couple of minutes. Hey, Fred, can you put in our email address, the stem-team@ti.com? Anything you need from a STEM point of view, from a TI point of view, just let us know. Reach out to us. This is a group email, so we all get the email. And we will get back to you right away. We'll set up time to get on the phone with you. None of us are salespeople. We're all former teachers or strategy people just trying to create some cool content for you to use. So our mission is not to sell you on this stuff. Our mission is to help you use it. And so so please take advantage of that. And Fred, with that, I'm done. Did you have anything else to share with the folks?
No, I think that covers it. I'm putting that link in just now, STEMteam -at ti.com if anybody wants to get involved with that. Other than that, Eric, stay warm and keep coding.
Yeah, and we have a question here, Verena. Yes, the answer is yes. When you fill out the form, we're going to send you the equipment that you request. We'll probably start with like a sample set, so you can play around with it and see how it works. And then if you like it, if you think that's something that'll work with your kids, then we'll send you class sets of the equipment. So yeah, you just fill out the form and one of us will get back with you. And no, you don't have to include the project dates at this time. We'll send you like a single set of equipment just for you. And then, like I said, when you're ready, let us know and we can work on the dates. We can figure out the dates. We tend to do a lot of camps and clubs around test time. So when the AP or state tests are complete, there's about a month period between the end of those tests and the end of school. And so we do a lot of work around there. And then also the summer. But honestly, we do things around the holidays. We do things throughout the year. So whenever it's convenient for you, we'll make it work. All right.
Well, Eric, that about wraps it up.
Hey,
So
Fred, thanks a lot. Great job. And good job on the demonstration. And we'll talk to everybody later. Have a good day, everybody.
Thanks.
Bye-bye.
Bye-bye.